Now to draw some graphs from our frequency table that we just created. We're first going to draw a histogram. A histogram is a bar chart, very similar looking a bar chart, but for quantitative data. And this is where the bars touch and gives us an idea of what our data is doing. So we need to create, I know most of you know how to graph, or I know all of you know how to graph, vertical and horizontal axes. Okay, on the horizontal axis, we're going to put our, label this whatever our data value is. So in this case, it is the distance to campus, and that is in miles. So the important thing with any graph you do is to make sure that you have labels on it. Okay? The vertical axis is the number of students or the frequency, but you want to put what it is, not just the word frequency. Okay, same thing down here. You don't want to put class. A lot of times students will write class limits or class boundaries or midpoint. You want to put the actual, what the data value is. So to create our bars, the edge of each bar is actually going to be our class boundaries. Okay, two ways that different textbooks or news media will show histograms. They will usually show the class boundaries here or the class midpoints. So let's just start off doing our class boundaries. So some books will only show that. Some instructors will say you have to have a scale here, like 1, 2, 3, 4, 5, like a graph scale. You know, for me, as long as you're close to the distance, we can say this starts with 3.5. And I'm just spacing it out for my class boundaries, which I have as 3.5 to 11.5, 11.5 to 19.5, 19.5 to 27.5, 35.5, and 43.5. The height of each bar will be the height of the frequency for that class. So my first class goes from 3.5 to 11.5, and the frequency is 5. Okay, so my vertical axis, I'm going to have a scale here. 5, 6, 7, 8, 9, 10. So my first bar goes 1, 2, 3, 4, 5, goes up to 5. Okay? The second bar goes up to 7. See how the bars touch? They have the same width because the width of each bar is calculated by our class width. The third bar again goes up to 5. The next bar goes up to 2, and the last bar goes up to 1. So the height of each bar, again, is our frequency. So this visually tells us most of our students drive in this area right here. Then it kind of trails off to the higher values. So when we look at histograms, one of the most important things we're looking at is what is the shape of our histogram? So as you already saw in the PowerPoints or you read in your textbook, some different shapes we can have to histograms. One is mound shape or symmetrical. And that would be if we drew a line down the middle, the bars would be equal on each side. Or if we put a smooth curve over it, it would look something like this. The height of the bars are here and they trail off on both sides. So it's a mirror image. Symmetrical means if I draw a line down the middle, it's a mirror image. Uniform or rectangular would be that all the bars are the same height. Something like this. Now you could say, isn't that, Professor Faber, isn't that symmetrical? And in fact it is, because if we draw a line down the middle, it would be a mirror image on both sides. However, it is not mound shape. The next one is skewed to the left. If we drew a smooth curve over our histogram, skewed to the left means most of the bars, the height is at the right and it trails off to the left. So when I say skewed to the left, it skews to the left. Skewed to the right means the height of the bars is on the left-hand side here and it trails off to the right, skews to the right. Bimodal would be if we had two high points in our data. Okay, so looking at our histogram, if we drew a smooth curve over this, which way does it trail off? That's right, it trails off to the right, meaning this is skewed right.